In this video, we are going to look at the concept of ionic bonding for your chemistry. Now, this topic is a very important one, guys. Pay attention here. All right, very important aspect of chemistry. All right, after going through this video, I guarantee you guys that you understand this concept of ionic bonding. So ensure you stay to the very end of the video. We also look at basic features or characteristics of ionic bonding. All right, so having known that, let's go into the details of the video. Okay, so we're looking at ionic bonding. Okay, now let's begin by knowing what ionic bonding is all about. Now, ionic bonding is simply a type of bonding that involves the transfer of electrons from an atom, usually metallic, to another atom, usually non-metallic. So ionic bonding basically occurs between a metal and a non-metal. Okay, so that's what you have to know. For instance, we have sodium chloride. Now sodium here is the metal, chlorine here is the non-metal. Alright, so there's a transfer of electron from a metal to a non-metal. In this case, the charge of this sodium is positively charged here, alright, whereas the chlorine is negatively charged. Alright, sodium forms a single positive charge, chlorine forms a single negative charge. So sodium transfer electron, we give that electron to chlorine. Chlorine wants to receive one electron, which makes it what? To attain stability. Okay, now another typical example is now let's use sodium hydroxide. Okay, now this sodium gives us an electron, whereas this hydroxide, a radical, will receive the electron. All right, this sodium positively charged, this hydroxide is negatively charged. That's basically what is happening here, guys. It's a transfer of electron between a metal and a non-metal. Okay, now note that all acids, all inorganic acids to be precise, are ionic compounds. They have ionic bonding in them. Examples of inorganic acid include hydrochloric acid. We have our triazo carbon 4 acid. We have our tetraazo sulfate 6 acid. Okay, we have our triazo nitric 5 acid and the rest of them. Note again that all bases are ionic compounds as well. They contain ionic bonding in them. Typical example is this sodium hydroxide. We have potassium hydroxide and the rest of them. Okay, we also have magnesium oxide. So this one this is a weak base, all right, and the rest of them. Now we also have salts. All salts are ionic compounds. They have ionic bonding in them. A typical example is this sodium chloride we have here. We have sodium chloride. We have our magnesium chloride. Okay, we have our zinc chloride. All right, so these are examples of salts, common salts. Okay, so take note of this. All salts, bases, and inorganic acids are what? Ionic compounds. They have ionic bonding in them. All right, now let me wipe this and show you. Now let's look at the dots and cross diagram showing how ionic compounds are formed. Okay, so let's wipe this. Okay, now note that, remember, we're looking at the dots and cross diagram showing how ionic compounds are formed. Okay, now this dot and cross diagram show the arrangement of electrons in an atom or ion. Alright, each electron is presented by a dot or a cross. Okay, so these diagrams can show which atom the electrons in an ion originally came from. For instance, let's look at the dots and cross diagram of sodium chloride. Sodium chloride. Okay, now the sodium atom gives up its outer electron, becoming a sodium ion, a single positively charged ion, whereas the chlorine atom picks up the electron, becoming a single negatively charged ion, or that is chloride ion. That one is now sodium ion. So let's represent them diagrammatically. So this is what will happen here. This is the atomic structure of sodium. This is the nucleus. This is the first shell. All right, this is the second shell. Follow me, guys. This is very interesting. You can't escape this topic in your GCSE chemistry. Alright, so remaining one shell. Okay, so let's draw the, or let's put the remaining electron here. This is sodium. Okay, sodium atom. Whereas this will be our chlorine atom. Let's draw the atomic structure. This is the first shell. This is the second shell. And this will be the third shell. Okay. Now, chlorine, as we all know, chlorine has 17 atomic number. Now, let me put this at this place so that it will be easy to illustrate. Alright, now, basically, this is chlorine atom. Okay, so the electronic configuration here, we have it to be 281. This one here is 287. Okay, now basically what will happen is that this sodium atom, since it wants certain stability, it will lose this electron to this atom here. All right, so when it loses it, this atom here will now gain the electron. When this sodium loses the atom, it now form a single positive charged atom to gain stability, whereas this chlorine atom will now gain the electron to now form a single negatively charged atom to gain what stability. Alright, so once this is done, the new structure will now be something like this. Let me wipe this and show you. Okay, now that the transfer of electrons has been made, our sodium ion will now be something like this. This is the atomic structure of sodium. This is the first shell. Okay, this is the second shell. All right, so it will now be okay. Now, since sodium has lost one electron, this will not be its new atomic structure. It will not be a charged sodium. Okay, a single positively charged sodium, whereas the chlorine that received the one electron will not be a single negatively charged chlorine, that's chloride ion. So this will not be the new structure. This is the nucleus. This is the second shell. Okay. This is the third shell. Remember, the third shell contains a mass number of 7 electrons, but because it has received one electron now, it will now be 8 electrons. Okay, so it's not completely filled. This will not be our charged chlorine. Okay, so it forms a single negatively charged atom. Alright, this will not be our sodium ion. The electron configuration will now be 2, 8, no longer 2, 8, 1. This one is our chlorine ion. The electron configuration will now be 2, 8, 8 instead of 2, 8, 7. Okay, so this is what we're going to have. Now let me show you the previous diagram when the transfer was occurring. Okay, so this was the previous diagram. This was when the transfer was occurring. Sodium atom was transferring this electron to chlorine atom. Alright, so when the transfer was done, transfer of electron was done, this now became our new structure. Okay, let me remove this. So this now became the new structure. They now formed ions to attain what stability. Very important, guys. Now let me show you. Let's look at another example. This time around, let's show the dot and cross diagrams of magnesium oxide. Let's wipe this. Okay, now for magnesium oxide. Okay, now the magnesium atom gives up its two outer electrons, becoming a magnesium ion. The oxygen atom picks up the electrons, becoming an oxide ion. So basically, let's draw the atomic structure of magnesium and oxygen when they haven't gotten charged, and then draw them when they have gotten charged. All right, so for when they are not yet charged, magnesium atom, this will be the atomic structure of magnesium. Okay, magnesium has 12 atomic number. Okay, so this will be the third shell. All right, this is for magnesium atom. Right, this will be for our oxygen atom. Oxygen has 8 atomic number. This is the first shell. This is the second shell. Alright, so this is our oxygen atom. Okay, now that we have drawn their respective atomic structures when they have not gotten charged, so the ionic bonding here now is that this magnesium atom will lose these two electrons to this atom, oxygen atom. So they will now come here. So when it loses these two electrons, it will now form a magnesium ion, normally a double positively charged atom or ion. Whereas this one again, oxygen will now form a negative ion, that's a double negatively charged atom or ion. So let's draw the structures now when the atoms have gotten charged. So it will now be something like this. Magnesium ion will now have this structure. This is the first shell. Instead of having 12 atomic number, now it will now have 10 because it has lost 2 electrons. So this is what we're going to have. Magnesium. So this will now be magnesium ion 2 plus. Alright, whereas our oxygen ion or oxide ion will now be something like this. This is the first shell. Instead of having 8 atomic numbers, now have what 10 because it's received extra 2 from magnesium. Okay, so this is basically what's happening here, guys. This will now be our oxygen ion. Okay, so that's basically what's happening here, guys. Initially the electron configuration for this one was 2 8 2. This one was 2 6. This time around that we have gotten charged is now 2 8, and this one is also what 2 8. Okay, so that's basically what occurred. All right, when the transfer of electron happened, they became charged to atoms. So atom was stability like that of noble gases. Okay, now let's look at one more example before we call it a class. All right, so after this example, now you'll be able to do it on your own. Let's wipe this. Okay, now don't forget to put the charge when it became charged atom. Very important, guys. Very important. This will now be our 2 plus charged, whereas this one will now be our 2 negative charged. Okay, very important, guys. Don't forget to close it like this to indicate that this is now what a charged atom. All right, now let's look at one more example, and after it you'll be able to do it on your own. Let's write this, guys. Okay, now let's look at the ionic bonding in this compound magnesium chloride. Okay, now in magnesium chloride, the magnesium atom gives up its 2 outer electrons, becoming a magnesium ion. The 2 chlorine atoms pick up 1 electron each, becoming 2 chloride ions. So basically, let's represent it, the dots and cross diagrams. Okay, so for when we are still atoms, not yet charged, we're going to have it to be something like this. So this will be the structure of magnesium. It has 12 atomic number. Okay, this will be the third shell. Now, for the chlorine atoms, it's going to be something like this. This will be the first chlorine atom. Okay, this will be the second shell. Chlorine has 17 atomic number. Okay. Now this will be the second chlorine atom. Follow me, guys. This is very, very interesting. Okay. And this will be the third shell. Now, this magnesium atom, what will happen here basically is that it will give out these two electrons to attain stability to become an ion. Alright, so these two electrons it will give out, they will be picked up by the chlorine atoms. Each of the atoms will gain one electron from these two electrons this magnesium atom will release. So when these two electrons are released, okay, so one will go to this chlorine atom and one will go to this chlorine atom. So for them to attain what stability. Now when this occurs, our new ionic structure of them will not be. Let me sketch it in another slide. Let me remove this slide and sketch the ionic structure in another slide. Okay guys, so the new ionic structure of the atoms will now be something like this. This is chlorine. This is second shell. Okay, so this will be the third shell. This time around, the chlorine has attained stability, is now charged. Now this will be the magnesium. Alright, and this will be the other chlorine atom. Okay, the both chlorines have attained stability now, looking like argon, noble gas, where the magnesium is looking like neon, noble gas. Okay, now let me show you the previous structures, the previous atomic structures. This is the previous one we had. Now, in this, remember that this is our magnesium atom. This is our chlorine atom. The electronic configuration here was 282. Here was 287. Here was 287. Alright. Now that the transfer of electron has been done, the new electronic structure will not be, let me remove this. So this is what it will not be. Chlorine will not be 288. The magnesium will not be 28. Chlorine here will still be 288. Alright, this is now our chloride ion. This is now our magnesium ion. Alright, this is now our chloride ion. Now don't forget to enclose it like this, indicating that it's now a charged atom. The chlorine forms a single negative charge. The magnesium will form a double positive charge, 2+. This chlorine also forms a single negative charge. All right. So this is basically what will happen when the transfer of electron between magnesium and chlorine happens. All right. This is magnesium chloride. Okay. So that's it for this kind of example, guys. This is actually what happened here. All right. Now I would have loved to end the class, but I want to show you one more example, very important, so that you know how to deal with any situation. Okay. Now let's look at that of sodium oxide. Let's look at the dots and cross diagram of sodium oxide, and after we can call it a class. Let's wipe this. Okay, guys, we are now looking at sodium oxide. Okay, now for sodium oxide, two sodium atoms each give up their single outer electron, becoming two sodium ions. All right, the oxygen atom picks up the two electrons, becoming what? Oxygen ion. All right, that's oxide ion basically. So what will happen here is, let me draw the atomic structure of sodium atom. We're going to draw two atomic structure of sodium atom and one of oxygen atom. So basically this is going to look like this. For sodium, this is sodium. Sodium has 11 atomic number. This is the second shell. Okay, and this will be the third shell. All right, so to have this will be the second sodium atom. Okay, so this is basically what we're going to have. This will be the third shell. All right, remember this is our sodium atom, whereas this will be our oxygen atom. Oxygen has 8 atomic number. Okay, this is oxygen atom. Now what will happen here is that these sodium atoms will transfer this electron to this. This one will transfer its own here as well. So when they transfer it to this oxygen will now gain 2 electrons and it will now attain stability. All right. Now these 3 atoms now form charges to attain what? Stability. Now the new ionic structure of them now will now be, remember, the electronic configuration of these atoms here will be, this one is 281. This one is 281. This one will be 26. Alright, now that they have gained stability, their ionic structure now will not be, let me show you, let me remove this. Okay, so it will now be something like this. This is the sodium atom. Alright, it now have 2 shells instead of 3. This will be the oxygen atom in the middle. Oxygen has attained stability. It's now like a neon gas structure. The other sodium will be here with the nucleus. All right. So this is basically what happened here, guys. Okay, now don't forget to enclose them. Since they have gained charges, sodium will form a single positive charge, oxygen will form a double negative charge, and this sodium will also form a single positive charge. Okay, now the electronic configuration will now be 2, 8. This is 2, 8. This is also 2, 8. This is sodium ion, this is oxygen ion, and this is what? Sodium ion. Okay, so this is basically what occurred here. The 3 atoms, the 3 charged atoms are now stable, having the same electronic configuration with that of neon. All right, so guys, this is basically how you can represent the dot and cross diagrams of ionic bonding occurring in ionic compounds. If you see it in your chemistry, of course, you will definitely come across this kind of question because this is a very important aspect of chemistry, bonding, particularly ionic bonding. Okay, before I call it a class, now let's look at the basic features of ionic compounds. Now, one of the characteristics of ionic compounds is that they form ions and not molecules. Now, note that another name for ionic compound is electrovalent compound. Electrovalent. Alright, so is it that I call it ionic compound or you call it what? Electrovalent compound, just like here. This is sodium oxide. So this is ionic compound or what? Electrovalent compound. Either of the names is correct. Okay, now one of the characteristics is that they form ions and not molecules. Another one is that most of them are soluble in water. Another characteristics of them is that they have high boiling and melting points. Okay, another characteristics of them is that they are good conductors of electricity and heat. All right, so they can conduct electricity. So take notes of these basic 4 features of ionic compound. There are others, but these are the main 4 you have to know. One more you have to know that they exist as solids at room temperature. So just know this 5. They exist as solid as what? Room temperature. So with this, let's call it a class. So we need something interesting from this video. Now, if you are new to the channel, ensure you check the description of the video below. We see a link to our Telegram channel. Click on it and join the Telegram channel for instant notifications. So ensure that you subscribe to this channel by hitting the subscribe button. More videos like this, like, share, comment on this video to tell me how you feel from what I learned from this class. Now, if you seem to have any specific questions to ask regarding this topic, feel free to leave a question at the comment section below, and I'm sure to give you a response. Okay, so that's it for this live, guys. Thanks for watching. Now click on the end screen above, and I see you in the next video.